All right, let's continue, and so let's continue how to drive the general quadratic formula. So like we have derivation of general quadratic. Writing on this white screen, whiteboard, is extremely difficult. All right, so normally we have our quadratic equation will be given to us like this, plus px, the general form, no time is missing, equals to q equals to 0. So they can even say use this, let's even take it like this. I want to reframe the questions. All right, you can say use x raised to the power of 2 plus px plus q equals to 0 to drive the formula, that is x equals to minus b plus or minus square root b raised to the power of 2 minus 4 ac all over 2a. So this is our tax. This is the tax given to us. So we have to use this to drive this. I have told you in the previous session before the video went off, I told you when this is given to you, first step you have to do is to restate the completing the square or the simple quadratic formula. You can restate this. X equals to minus p over 2 plus or minus p square over 4 minus q. If you notice, this is what completing the square formula. So we can use the completing the square formula. Remember, it is from this we have completing square formula. So it's from completing the square formula we will use to get the quadratic formula as well. So first step is to state this, the completing the square formula. So from there, what you need to do, you need to know what is P, and you need to know what is Q as well. So here, we know that P is what? B over A. And we know that Q is what? C over A. So all what we will do here is to substitute. We know this. We will substitute this into this, and we substitute this into here, and this also comes here. So you realize that our our step 3 will be x equals to, if we said p, so it will remind us what is p. P is b over a over 2 plus or minus in square root, say p, and our p is what? B over a raised to the power of 2 or squared all over 4 minus q, which is c over a. So we can come here with this, and x will be what? X equals to, so this one we have to do a little bit of algebra manipulation. So this term we can express it as what? Minus b over a. It's just minus, it's like b over a divided by 2. So you just invert it, you know, using multiplication. It will be 1 over 2, we have that in bracket, plus or minus square root. So we have what? B over a also is very simple. We can manipulate it by inverting the denominator over a over 2. We have this then times 1 over 4. Then we have a bracket for them. Then minus c over a. We have this. So we go, then we have this. We will have this times this, it will be equals to minus b over 2a plus or minus. So this will give us what? This will be b square all over 4a2 minus c over a. We have this. So we will continue with this on the next slide. So we will rewrite this again as, let's divide this into 2. Oops. All right. All right. So let's continue. X equals to, from where we stopped. So we said that equals to minus b over 2a plus or minus in square root b, this is 4ac. I'm rewriting what we done in the last slide, what we have done. We have this already in the last slide. So we have this. So first thing, we have to deal with the expression within the square root. So, and first that we should deal with is to get rid of these fractions. They make work difficult to do, so we get rid of it. And to do that, normally if you want to get rid of a fraction, you find the lowest common denominator of 4a squared and then a. So if you look at this, we will find the denominator of this will minus b over 2a. We haven't touched that yet, but we will come back to it. Then over, we want to get rid of these fractions, you understand? So we have to find the lowest common denominator of 4a squared and a. So these two, they are LCD, that is lowest common denominator, algebra, basic algebra high school. Lowest common denominator is what? 4a squared. So what we mean by lowest common denominator, you look for a numbers or variable or a mixture whereby this 4a2 can go without a remainder, and this one also can go here without a remainder. Check it out. 4a squared divided by a is very simple. What it means is 4 times a times a all over this. So at the end of the day, we cancel this. So it will be 4a. So it goes there exactly without no remainder, and it's 4a times. So this 4a2 will be our lowest common denominator. So 4a squared into this, it will be 1. That 1 times b squared, it will be b squared. Then minus a into 4a squared is 4a times. That 4a is 4a times c, it will give us 4ac. So we keep going further. X equals to, we bring down our minus b over 2a plus or minus. So here we will find this one, we will find the square root of it already, but not the one. We find the square root of the numerator. Equivalently, if we even want, we can express this. If you remember, so I think sorts in high school, we can say this. This is the same thing as this as well. So x will be equals to, here they share this, now we are separating them as here. So this will be minus b over 2a plus or minus. So still we go with this, b raised to the power of 2 minus 4ac all over, what is the square root of 4 is 2. The square root of a squared is obviously it will be a. Because if you have this a and 2 is here, obviously it's nothing but a this over 2 times 2. So it will cancel, so you will only have a. So it's what this a that we have here. So continuing from here to here, we will have x equals to minus b over 2a plus or minus, I'm rewriting it, well, continuity, easy of continuity, plus 4ac over 2a. So we have to combine these two expressions together, and to do that, we have to find the lowest common denominator of each of the expressions. So obviously the lowest common denominator of 2a and 2a, obviously it will be what? 2a. So 2a here into 2a here is 1. 1 times minus b is b. plus or minus 2a into here is 1, into here is 1. We multiply it by the square root, it will give us the same square root. Minus 4ac. So this is the quadratic equation that we have been talking about. Now we have derived it. We have derived it. So I also want to talk about this quadratic equation, the general quadratic equation. This is the general quadratic. The general quadratic equation. Let's look at the formula and discuss certain features about it. This is not I'm not having mathematics majors. It's just, we will discuss certain features that I think you should know about them, or you should pay attention to them whenever you see quadratic equation. So this is the general, we have derived it. But let's go further and look at the formula in bit detail in the next slide. So these are some of the things you should note about the quadratic formula. So we have the formula as this, minus b plus or minus in square root. We have b raised to the power of 2 minus 4ac all over 2a. And the first thing you should know about that's the condition. For us to use this formula, what we have within the square root, this term. And in mathematics, they call it discriminant. What we have within the square root should not be less than 0. So this is the condition to use the formula. B raised to the power of 2 minus 4ac should be what? Should be greater than or equals to 0. Why is it that? If it's this not equals to 0 or greater than 0, it will be negative, and you cannot take a square root of a negative number. So the condition is that the discriminant or this expression should be 0 or greater than 0, meaning that should be a number that starts from 0, 1, 2, 3, it goes up to infinity, but it cannot be a number less than 0. It cannot be negative because we cannot take a square root of a negative. So that's why they have this first condition. This is the condition that must hold for us to use this general quadratic formula. So another thing that I want you to note about this is this. So in case we calculate when b minus, when this holds, that is b, and we have minus 4ac is greater than or equals to 0. When this holds, then we will have a solution. Not all quadratic equations have a real solution. How do you know that it has a real solution? It's that this b raised to the power of 2 minus 4ac should be, the answer that you have should be greater than or equals to 0. So when that holds, when this holds, then we can say there is a real solution. So then there is a real solution. There is a real. Remember the word real solution. It's important, the word real. I'm sure that if you have done mathematics at higher level, there are imaginary numbers that we have, but that is beyond this class. But when this whole, for example, let's look at what we have solved before. X raised to the power of 2 plus 8x minus 9 equals to 0. We know here A is what? 1. B is what? Plus 8. And C is what? Minus 9. So if you want to know whether this quadratic have a solution, you can just use this discriminant expression. So what is the expression is B minus 4AC, and what is our B is 8 minus 4 times A is what, 1 times minus 9. So 8 raised to the power of 2 is 64, I guess. Yeah, it's 64. 64, then minus and minus, it will change into plus. 4 times 8 is how much? 4 times 9 rather. 4 times 9 is 36. So at the end of the day, we have 100 as our discriminant. So if this 100 is what? Is greater than 0. So the condition holds. So meaning that if this holds, if this is true, then there is a real solution, is what we mean by this. And this condition holds because we solve this and we have 100, and 100 is greater than 0. But in a case that we have a number like maybe instead of 100, we have like minus 10, then there is no solution. So these are some of the features I want you to pay attention when you are doing quadratic equations as well. So, but there are certain times when the discriminant, when B, so there is a real solution, and there is a real solution, and the solution here we have for these lectures, we remember is we say that x equals to 1, x1 is 1, and x2 is minus 9. So these are the real solution. So when B square or the discriminant is positive or greater than 0, then we have a real solution, and it will have what? 2 roots. But in a case where we have this minus 4AC is equals to 0, we will have a solution, but it will only have 1 root. So instead of x1, x2, we will only have 1 root or 1 solution. So there will be only 1 solution. There is a, or let's even put this in a better way. There are 2 real solutions. But in this case, there is 1 real solution. So these are some of the things you should watch out when you are doing quadratic equations. Okay. So another thing also I want you to pay attention, the materials I shared with you is having some of these things. So you have to read them. You have materials, you have lectures, and you will have access to this also as well. So I think this should be sufficient. Also, what I want you to know is like, if you said, you know, if x1 plus x2. So remember that the x1 and x2, they are the roots. They are the roots of the equation. When you plus the roots of the equation, they should give you minus p. And when you multiply the root of the equation, that is x1 multiplied by x2, should give you q. So let's confirm this. When we solve this equation, our x1 was what? Was 1, and x2 was minus 2. So let's confirm this. X1 is what? 1 plus, what is x2? Minus 9. Let's see this. Our p is what? Is 8. So it says minus 8. So 1 plus minus 9, obviously it will give us minus 8 equals to minus 8. So this always holds. So what it is telling you here is very simple. if you find a solution to quadratic equation, if you add their roots, it should give you what? Minus p. So here, what it's telling you also is very simple. If you multiply the roots of the quadratic equation, they should give you the constant. So we know that when we solve this, we have x1 and minus 9. X9 and so x1 is what? Let's try to prove this. X1 is what? 1. So 1 times x2 is what? Minus 9. So our x here in the equation is what? So our q rather. This x1 is 1, x2 is 9, which is here, that's the solution. And our q is what? Minus 9. So this times this will give us minus 9 and the equation will hold. So these are the 4 features that I think you should pay attention to when you are dealing with quadratic equation. As you go on to do further maths or higher mathematics, you will understand they have a lot of application in mathematics. So 1, 2, 3, 4, let's pay attention to them when we are dealing with quadratic equations. So let's take a practical example, another example here to see. Let's take a real life example or real life application. You have this example in your maths on the materials I gave to you. You can check it in your books. So they asked us to solve for a variable. So this equation is given to us. You can find this example in the materials I gave to you. It is given to us as m equals to maybe let's stop here until the next class. The internet is stable, electricity has gone, and my battery, it doesn't last that long. But if you have any question before we go on, you can ask. If you have an observation, you can share with the class, or if you have a comment, you can share with the class. As I said always, the goal is to improve the quality of the class, each online lectures. It's not easy. Before the lectures, I have to prepare a lot of stuff. And even after the lectures, I have to still engage with you. So I hope we will go back to the traditional way of delivery. And that's the prayers, because from my end, I prefer to be in class than to be here. It is more interactive. You can learn 1 or 2 things from the students' faces when they don't understand. Unfortunately, we can't do it. So if you have any observation or comment or anything that you want clarification, you can go on and ask, please. Yes? If you have anything you want to share, you can go on, please, and share. I'm seeing 6 students out of, I don't know, 20 something or 30 students. I don't know whether it is rain or not. But we have to do our lectures irrespective of what is happening. We have deadline that's...
Let just went. I know that's the reason why most students are not online.
Yeah, let's clap for Nawek for job well done. That's why I wanted to stop here so that I will not cover a lot of materials whilst most of the, or half or more than half of the class is not around. I think we have we have done a lot today. I will try to share this videos on the YouTube channel. It is last time somebody suggested we go back to the campus. I said, yeah, I cannot defy those orders. They are executive orders, and besides, if it's
Yeah.
going to happen, it has to come from the school administration, not from the lecturers.
Yeah.
You don't
Yeah.
want to put the school in trouble. If they decided
Mhm.
for us to go back, the lecturers, why not? I prefer that. And to be frank, I put more effort in these lectures than the traditional way. You prepare material after the class. Preparing video also, it takes time to upload them or to trim them down.
Yeah, it's
So
difficult.
it's difficult, and I don't feel like it's like a traditional way of lecturing. But let's be hopeful and let's engage each other. And if there is a way you think the lecture can be improved, I like comments. I like to bring people on board.
Yeah. Yeah.
All right. If there is no question, then you people have a great weekend. And please go over the materials. I have shared exercise. Go through those exercises. If you can solve them, the ones I circle, you will be fine for this class or this lecture or this course.
But so if you solve it, if we having mistakes, we will consult it through WhatsApp then.
Yeah, you can consult me. I might not take it. What I will do, I will bring all the problems together. One day we just say the problem session. We solve only those things.
Yeah. Yeah. That would be nice.
Yeah,
That would be great.
yeah. But I'm praying we go back to the class. It's very time
Yeah.
consuming.
Yeah. Yeah.
Yeah.
Yeah. Yeah.
Okay. All right, guys.
Hopefully, maybe before next 2 weeks.
Hopefully.
Hopefully. Yeah.
All right, guys. Have a nice weekend and please study. And those exercises,
All right. All right.
they are very key, and if you can solve them, it should be comfortable. You don't have to worry, but you have to go through them, solve them, keep them. And some of the assignments, most of the assignments will come from there. I can just come and I say that do
Okay.
question exercise 1, 2, 3, or 5 as exercise and submit it. So if you have solved it already, you just copy it and paste it in another paper. That's all.
Yes. Okay. Okay.
All
Thank you.
right, bye-bye, guys.
All right. All right.